use a calculator to solve this equation. Sine of theta equals 0.8. By the way, this is a ratio, not an angle, okay? And they want the angle for theta in radians. So we want the angle in radians, okay? Now, we know and we learned about inverses, but this original problem does not have inverses attached to it. So we might use inverses to solve it, but there's no actual inverses on it. So here's what I mean by that. When you're thinking about your unit circle, this is the ratio of 0.8, so it's not quite the 1, right? So the y values are not quite 1, positive. So it's going to be about here somewhere and about here somewhere. The issue is this. I don't have that on my unit circle. 0.8 for my y values is not on the unit circle. So I don't have it memorized. Okay? But I do see that there are two places. I'll have to fill in this spot, right? I don't know. But I could go all the way around afterwards. Same thing with the one in quadrant 2. I don't know what it is, but I could go all the way around afterwards, right? So I'm going to do this. I'm going to say, if I use my inverse sine, it will find the quadrant 1 solution. Because remember, inverse sines only produce one outcome. So we can find the one in quadrant 1 using our calculator and inverses, and the rest is up to us. So I'm going to grab my calculator. I'm going to make sure I'm in radians, and I'm going to do inverse sine. So theta will equal arc sine or inverse sine of 0.8. Okay. Clear all. Okay. I am in radians now. Inverse sine 0.8. I get a radian measure of 0.927295. I will round, maybe too early. 2952, 2952. 2952. Now that's the angle in radians. That's going to be this one here. Right? That's that angle. This one over here, there's symmetry, right? To get that same y value, we gotta have symmetry. So there's symmetry here. So if this is 0.927, then this inside one is 0.927. The issue is I don't want that inside one. I want the one that gets me over there. That was too dramatic. I want the one that's gonna get me over there. So the other angle is pi minus 0.927. Okay? So what does that mean, right? The calculator could only find one, but our brains have to work and kick in to find the other one. Check. Got it. So what is pi? Let's see. Pi minus the previous answer. 2.2143. 2.2143. 2.2143. That is that one in quadrant 2. The one in quadrant 1 was 0.9273. Now, if we want to solve all of them, they have that 2 pi k on there. These are all the solutions forever and ever. We had to use inverse to find one, use our brains and kind of a visual image to find the other. Okay? I would like to show you one other way that students have done this. They understand that you'll find one and the other one is up to you to find. With our calculators, what if you could do this? What if you could take a graphing calculator? This is a sine curve. So the sine curve, remember, looks like this. Point 8, it's not quite 1. So my 0.8 is going to happen here, and here, and here, and here. Let's get our graph to continue. And here, and here, and here. And the process is going to continue, okay? If this one was 0.9273, and this one, 2.214, one full period later, it will happen, and again and again and again. But how do you find them if you're looking at a graph? There's a sine curve. Next one is going to be y equals 0.8. Okay? So if you have that graphed, where's their intersection? (0.9273). 2.2143. Those are your two. And then they repeat every period. A couple different ways you can use your calculator. All right. Sometimes fun stuff happens, or non-fun stuff happens. We could use, for this next one, maybe we'll take the graphing approach. It'll be maybe slightly faster, but I really like, well, I don't know. I like the visual approach too. Secant, hard to work with secant. Let's change it into 1 over cosine. So this means if I flip this, I have cosine of theta is equal to a -1/4. Visually, it's not going to be on our unit circle, but it's going to happen negative, wrong spot. Negative is here, negative is here. So those two spots. Well, where is that happening? Well, this is our unit circle, visual of it. Our calculator, if we do inverse cosine, it'll give us the one in quadrant 2, but not the one in quadrant 3. Inverse cosine of -1/4. Oh, let's just clear off. Inverse cosine of -1/4 is 1.823. 1.823 gets you all the way there. Okay. Plus any full cycle later. What is this one down here? You can go, it would be kind of tricky. I think an easier way, you could certainly, you know, if this is the 1.823, then you could do 2 pi minus, right? Minus 1.823. And those are your two angles. And actually, I'll go one step further and say those are all the angles forever, because you had the 2 pi k on the back end saying we're just going to keep going round and round till we land there and get the same ratio. Okay? Could we graph this similarly to this? Find the values? Absolutely. All right. And the properties of right triangles. We're going to model the equation that fits this problem. One of the cables that anchors the center of the London Eye Ferris wheel to the ground must be replaced. The center of the Ferris wheel is 69.5 meters above the ground. The second anchor is 23 meters from the base. Approximately how long is the cable? And what is the angle of elevation from the ground to the center of the Ferris wheel? All right, so they want to know this length. I will call it C. And they want to know this angle theta. Okay, well, the easy one will be C, which is Pythagorean theorem to find that. So Pythagorean theorem, a leg squared plus the other leg squared equals the hypotenuse squared. So grab your calculator, do some math. Which means the hypotenuse, or in other words, the cable, is 73.2069, and this would be meters. Okay. Now to find theta. Angle. They don't say degrees or radians, so we could go either way. I can see that if I want, I could set up a tangent of theta is equal to opposite over adjacent. Okay. If I apply the inverse tangent on both sides, theta equals, and we grab our calculator. I'm in radian mode. Inverse tangent. Actually, let's clear everything. Inverse tangent. We had 69.5 over 23. .2512 radians. 1.252, I don't remember what it was, radians. And if you had done this in degree mode, it would be 71.69 degrees. Okay, let's look at this next example. OSHA safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. So 1 foot for every 4 feet of ladder. Find the angle that the ladder, find the angle that a ladder of any length forms with the ground and the height at which the ladder touches the wall. Okay, so basically this is if you have a 4-foot ladder, right? 1 foot from the wall, here's the wall. So basically if you have, say, a 16-foot ladder, that's 4 times longer, then this needs to be 4 times longer, right? So it's all proportional. I'm going to keep it simple. 1 for 4, okay? So the question is, find the angle. They're asking for this angle in here, and the length. Ladder of any length which the ladder touches the wall. Oh, wait, we don't need to know the length. Okay. Oh, and the height at which the ladder touches the wall. So I do need to know this. Okay. Well, let's do this. Suppose this, instead of 1, we'll call it x length for a 4x length ladder, right? That's a 1 to 4 ratio. Therefore, if we go Pythagorean theorem, wall length squared plus x squared is equal to 4x squared, because that's the hypotenuse. So the wall length is going to be 16x squared minus 1x squared. Wall length squared is equal to 15x squared, which means the wall length is equal to the square root of 15x, because you would square root both sides. Okay, so that's the second part, the height of the ladder, right? And now we need to find the angle. And I think since we know that the ratio is 1 to 4, I'm going to go back to what I have in black for the sides, okay? This means that the, I'm going to say cosine, that the cosine of angle theta is equal to adjacent over hypotenuse. Inverse cosine on both sides. Grab your calculator, degrees or radians, whichever. I'll do this one in degrees. Inverse cosine. Whoop. Of 1/4, 75.52. And now I'm in degrees. 75.52, and that was degrees. Make sure you label it if it's degrees. Your instructor will thank you. All right.